Okay, so first of all, in terms of syllabus from calculus for the test coming up on Sunday, it will be up to methods of differentiation. So make sure you are clear with the basic formula of differentiation, okay, the concept of instantaneous rate of change, the concept of average rate of change of a function, and in particular, you are well practiced with the application of chain rule, right, quotient rule, and the product rule. Okay,
sir, applied questions won't be coming.
Yeah, just one. Okay, so first of all, like the bulk of the questions will be from direct differentiation questions, and in that, like particularly, you have to be careful about knowing the application of chain rule, quotient rule, and product rule. Then applications of differentiation, only basic type of questions, differentiation as a rate measurer, like the type of volume and area type of questions that we have discussed. Okay? Those kind of questions will be coming. But very less in number. Okay, so more number of questions will be related to the direct differentiation and the different techniques and methods of differentiation. Now, the more advanced questions in application of differentiation, like the maxima, minima, which we are going to discuss ahead, we haven't started that yet. Then also the constraint relations, how to use differentiation in constraint relations. So those kind of things will not be coming in this test. They will be in the next test. Okay, is the point clear, people?
Yes, sir.
Any doubt?
No, sir.
Okay. In particular, like make sure your worksheet number 1, 2, and 3 is 100% clear. Okay. Okay. Now let's start with basic recap of some of the concepts that we learned last time.
Sir, I have a doubt from the
Yeah, I'll come to
worksheet.
the worksheet doubts. Okay, just give me a moment. Okay. So one of the things that we were looking at in the last lecture was behavior of a function from the value of its derivative. Dy by dx, which in short form we also call as f prime x. So what we understand about the behavior of a function from the value of its derivative, which is also in a sense the application of differentiation. So what we had seen is that if the graph of a function is such that y is increasing with respect to x. So in a certain region, the behavior of the graph is like this. Okay. It might not be a straight line. It can be a curve also like this. Okay. But the important thing is y is increasing with respect to x. So then at any point, if we draw the tangent, it will have a positive slope. Even if the curvature later changes like this. You can see it, the tangent at any point will have a positive slope. But in any other region, if the function now starts to, y starts to decrease with respect to x, then in that region now, if we draw a tangent at any point, it should have a negative slope. So basically it tells us that if there is an interval, let's say we select some sub-interval of x over here, like I've taken this point as a and this point as b. So for example, at any point between a and b, you can see in the graph that y is increasing with respect to x. Of course, it's increasing after b also for some time, but now I'm specifically talking about the interval a to b. So you can see here that if y increases with respect to x for x belonging to a certain interval, let's say ab, a to b, that is okay. This basically means that x is greater than a, less than b, that particular interval. Okay. Then dy by dx, or the derivative, will be positive for that same interval. Whereas again, you can see in the second part, if we select some subinterval like c to d, and we know that y is decreasing with respect to x for all values of x in this interval c to d, then accordingly dy by dx will be negative in that interval. Okay. So if y decreases with respect to x for a certain interval, let's say c to d, then dy by dx will be negative in that particular interval. So let's illustrate this with a simple example. We have, let's say, y is equal to sine x, okay, and we are looking at the interval in general 0 to 2 pi. So x is greater than equal to 0 and less than equal to 2 pi. Now within this, we have to find the intervals in which y increases or decreases with respect to x. Okay. So one option is we already know the graph of sine x, so we can refer to the graph and come to that. Okay, but the other option is we can also use differentiation. So now we can understand that the rate of change of this function or the derivative of sine x is equal to cos x. Yes. So this is the derivative of the function. So therefore, dy by dx is greater than 0 implies that cos x is greater than 0. Okay, and we know that that happens for x belonging to 0 to pi by 2. Okay, union with 3 pi by 2 to 2 pi, right? Or between x
0 to 90 degrees.
0 to 90 degrees, but not including 90 because cos 90 is 0. Okay, union with 270 to 360 degrees. Again, not including 270, but including 360. Okay, so that means sin x increases with respect to x for the same interval. For the same interval.
So why did you put 3 pi by 2 there?
Because 3 pi by 2 is the fourth quadrant, ना बेटा? 3 pi by 2 to 2 pi is the fourth quadrant, ना? So fourth quadrant में cos का value क्या होता है? Positive होता है? Remember ASTC rule?
Yes.
So for example, cos of 300 is equal to how much? It is plus of cos 60, or it is half. But on the other hand, third quadrant cos is negative. So cos of 240, for example, will be again sine of 30 or half, right? But minus half, so not cos of 240 will be minus half, whereas cos of 300 will be plus half. Just an example.
Sir,
Yes.
sir, we know the general trend of the cos x in 0 to 2 pi. But what if I say that x belongs to range of 7 pi to 8 pi? Then what shall we do?
What if x belongs to
7 pi to 8 pi or any larger number?
7 pi to 8 pi is fine, na? 7 pi to 8 pi is the same thing as pi to 2 pi, no? From the circularity principle, na? Every time you complete
Yes,
2
sir.
pi, you're back to 0, you know?
Yes,
So
sir.
7 is what? 2 plus 2 plus 2 plus 1, na? So it's equal to
Yes,
1 times pi only, right? So for example, if I just give a very arbitrary theta, like theta is equal to, let's say, 15 pi by 4, and I ask you to find cos theta or sine theta or whatever. So 15 pi by 4, you can write as what? You can, for example, write this as 16 minus 1 into pi by 4. This would be an easy way to understand this. Okay, so that would be 4 minus 1 by 4 pi. So that would be equal to 4 pi minus pi by 4. So that's equivalent to minus pi by 4.
Yes,
So
sir.
cos of minus pi by 4 would be plus 1 by root 2. But sine of minus pi by 4 would be minus 1 by root 2. Right?
Yes, sir.
So for any angle above 360 degrees or greater than 2 pi, you can always use the circularity principle. Okay. Now,
Okay,
just
sir.
to complete this problem, on the other hand, dy by dx is negative, implies that cos x is negative. Okay. So that, as you can see, is the entire second and third quadrant. Okay. So it is greater than 90, but less than 270 or 3 pi by 2. So sin x decreases with respect to x for this interval. This interval. Right. Now, just make a note of this example. And next thing I want you to do is make the graph of sin x yourself. You know that wave kind of graph, okay, from 0 to 2 pi or 0 to 360, and just correlate the information that we got here. The first information we got that sin x increases in this interval. And the second information we got is that sin x decreases in this interval from 90 to 270. And you'll see how the information in the graph correlates with what we have got from differentiation. Right? Just try this out, people. I'll make the graph in a moment. Okay, but note this down first and also make a graph of sin x and correlate the information that we got. Sorry, beta. Can you repeat the question, beta?
So it seems like they accidentally unmuted. Done, sir.
Okay, people. So hope you have completed the correlation of this with respect to the graph of sin x, right? So if we look at the general graph of y is equal to sin x, being familiar with that concept from trigonometry, right? So we can see that sine x's graph is like this.
Wave pattern between 0 to 1 to 1,
Yes.
minus 1.
Looks like, in fact, this is called the sine wave. So if I'm limiting my graph only up to 2 pi, and then of course, it repeats itself, but here I'm limiting my graph only to so these are the most important points on the graph, right? Because these are the values for which the function first rises from 0 to 1, okay, then comes back from 1 to 0, then again drops from 0 to minus 1. Okay. So you can immediately understand that from the graph we'll get the same information. From the graph, if we were to see how y and x are related to each other in terms of increasing and decreasing function, so you can see that y increases with respect to x. For x going from 0 to pi by 2, but not including pi by 2, because at pi by 2 it becomes flat, the tangent becomes flat. Then y decreases with respect to x for this entire thing from pi by 2, so not including pi by 2, but open interval pi by 2, right up to this point where it's become minus 1, so 3 pi by 2. And then again, you can see that y increases with respect to x for the last part, that is 270 or 3 pi by 2 going up to 2 pi. Now, this is exactly the same information that we got by the differentiation method. Okay. So this becomes an important tool in analyzing any unknown function. Like here we know sine x is graph, so we could have analyzed this information where y is increasing and y is decreasing by the graph directly. We did not need to use differentiation because we know the graph of sine x from before. But if we have some other function where the graph is not known to us from before, then this becomes an important tool for finding out the this particular behavior of the function, that which part of the domain, that is for which interval of x or which intervals of x, y is increasing and y is decreasing accordingly. Okay, so let's pick up another example question. Okay, then we will come to the doubts and questions that you have from the assignments, etc.
So can you show the graph part again?
Yeah.
Thank you, sir.
Yeah, it's clear. Okay, Yashwardhan, done. Okay. Okay, so next we'll look at another question. So we have this function y is equal to 4x minus x square. Okay. And we want to do the same thing. We want to find the intervals for which y increases and decreases with respect to x. Just try this out, people. I'll put up the solution in a moment. Okay. In a minute or two, I'll put up the solution. Just try it out yourself. This is 4x minus x square. Okay. Write it more clearly. Y is equal to 4x minus x square. So as you can see, it's a quadratic function. Okay. So just find out the intervals of x for which y increases or decreases. You can drop me a text message with the answers. Yes, Jitendra, your answer is correct. Very good. Vidhi, your answer is correct. Very good. Vineet, your answer is correct. Darsh, your answer is correct. Parv, answer is correct. Very good. Okay, so let's understand this. Okay. So first of all, the correct answers, let me give you that y will be increasing for x belonging to the interval minus infinity to 2, and y will be decreasing for the interval 2 to infinity. Or in other words, you can just say that y increases for x less than 2, okay, and decreases for x greater than 2. So most of you got the answers correct. Yes, Sambhavi, your answer is also correct. Okay. So the method of doing this will be, again, the function is 4x minus x square. So the derivative of the function is 4 minus 2x, or we can just factorize this and write it as this. Okay. So now we can see that dy by dx, or the derivative, is greater than 0, implies that greater than 0. So that means that 2 minus x is greater than 0, which means that x is less than 2. So dy by dx is greater than 0, less than 2. We can also write like this, that minus infinity to 2, or we can also write it like this, that x is from minus infinity to 2, but not including 2, because dy by dx is 0 at x equal to 2, and less than 0 similarly implies that 2 minus x is less than 0.
Why do we
Means
put
x.
minus infinity?
Because here, there's no restriction in the domain that is given to us. Like in the sin x in the sin x example, I had given you in the question itself that x is from 0 to 2 pi. So you have to break that interval of 0 to 2 pi into sub intervals where the function was increasing or decreasing. So those sub intervals were 0 to 90, then 90 to 270, then 270 to 360, right? Here, no particular domain is given for the function. That means we have to assume here that x itself is the sum of is the is a set of all real numbers. In other words, x belongs to the set minus to plus infinity. Understood? No? You're taking the entire number line as your domain. Okay, but understood this point?
Yes, sir.
So when no restricted domain is given as part of the question, then you have to take the largest possible domain you can take. So here the function is such that y is defined for all real values of x. Okay, but sometimes you can have a function which is not defined that way. you could have a function, for example, which is this thing. It is, let's say, square root of, x square minus 1. Now here y is not defined for all values of x. Y is only defined when x square is greater than equal to 1. So here the natural domain of the function itself is that x is greater than 1 union with x is less than equal to minus 1. Okay. So here the values of y between minus 1 and 1, the values of x are not defined only, are not allowed only because y is not defined in them, right? You understood this point, beta? Okay. So again, coming back to this is
So why is the value of y not defined here?
here between minus 1 and 1, because see, x square will become less than 1. So square root of a negative number is not defined.
Okay.
Well, later you will see in maths there's something called imaginary numbers as part of a chapter called complex numbers. But that is not the point here. Imaginary numbers are not part of real numbers. So here we have to assume that y should be a real number. So for y to be a real number, x square has to be greater than equal to 1. X square should not be less than 1, because then the quantity inside the square root will become a negative quantity. So square root of a negative quantity is not a real number, right?
Yes.
Okay. So we can say that x belongs to the interval 2 to infinity, okay, greater than 2, but going up to where? Okay, so there's no restriction. So going all across the number line from 2 onwards. So that's 2 to infinity. Okay. So now you can see that therefore the function increases for x belonging to this interval, and then the function decreases for x belonging to the interval 2 to infinity. So here I don't have an idea about the graph of the function, but I have already got this information about the function. Okay. Okay, so having done this example question, okay, I'm just going through some of your questions in the text messages. Okay. So somebody you have asked, while finding out the domain, should be considered differentiation or the main question? No, so we should consider the main function only, okay, while considering domain of the function. When we are looking at the domain of the function y equal to fx, now we should not concern ourselves with the differentiation of the function. We should just concern that y is real for which values of x. So that becomes the domain of the function. Okay. Priyam, to answer your question, is there no particular set given? We can take infinity to minus infinity as the set. Yes, that's correct. If there is no particular domain set given for x, then we can take minus to plus infinity, provided y is defined for that entire set. Okay. But whereas if the function itself is like y is equal to root x, then we have to take the domain as 0 to infinity. We cannot take minus infinity to 0 in that.
Yes, sir.
It's a little bit also about the nature of the function given. Okay. Anyway, so this domain thing will not be so important for us in physics. Okay. Because anyway in physics, when we are talking about application of function, the domain will be understood very well. For example, suppose we have as part of our physics application, we have something like this, that displacement is equal to 5t minus 2t square. Okay, this is a displacement time thing. Now if you look at this as a function, it would have been y is equal to 5x minus 2x square. So as a function, I would have said that okay, x can be from minus to plus infinity. But now this has a particular meaning. T is time over here. Now we never take negative time. So therefore T obviously has to be in the domain. T has to belong to 0 to infinity. Or T can only be greater than equal to 0. We should not consider T to be negative. So as a physics problem, if we are looking at the graph of S versus T, we will not bother about the negative part of the graph, the negative part of the time axis. We'll only bother about the non-negative part, that is from 0 to infinity. So it's a little bit about what we are applying the function for also as far as the domain is concerned. So that is going to be usually quite clear for us from what we are dealing with itself. Okay, okay, now I'm going to solve. No, somebody, to answer your question, in the previous question, it does not include the point 2. No, this is basically x greater than minus infinity less than 2, because you can see that derivative is exactly 0 at x equal to 2. If you see the value of dy by dx, now you can also understand from this that dy by dx will be equal to 0 at x equal to 2. So that is why this point x equal to 2 will not be included in this thing, or it will not be included in this thing.
Okay, sir, clear.
Understood. So basically the graph will be something like this, where actually this will be the point 2. So at 2 it just about reaches that peak. So up to 2 it's increasing, and after 2 again it's decreasing. Okay, so before I come to the assignment doubts, okay, it's just a question that I think Vineet had, right? Somebody?
Yes, sir.
Yeah. What was it? Y is cube root of 1 plus tan to the power 4x. Okay, and we have to
Yes.
find the derivative of the function. So
Yes,
this is
sir.
like an extreme example of application of chain rule. Okay. Why I'm saying extreme is because you'll have to apply chain rule twice over here. This is cube root, right? Okay, cube root of 1 plus tan to the power 4x. Now in this we have to find dy by dx. So why I'm saying this is an extreme example is because if you think how the function is constructed, from x we have first operated tan, right? So we got tan x. So let's say this is equal to z. Okay. Then we have operated 1 plus z to the power 4, that type of function. Okay. So we have got 1 plus tan to the power 4x. And then we have operated square root. So let's say this is some u. Okay, so we have operated square root of u. So we have got
So cube root, right?
1 plus or cube root, sorry. So you got cube root of this. So it's like a double layer of composite function. So what we'll have to do is we'll have to do a substitution step accordingly. We'll have to substitute. So let us say this quantity 1 plus tan to the power 4x is whatever. Here I've taken it as u. Okay. So let's take it as u. So that means y is equal to cube root of u, or u to the power 1 by 3. This is the first thing. Okay. But then u itself is like this now. So we'll have to take tan x as suppose z. So that means u becomes 1 plus z to the power 4. So this becomes our second way. So basically z is a function of x. Okay. U is a function of z. Okay. And y is a function of u. See, z is some kind of function of x, let's say. Okay. Then u is some kind of function of z. Okay. So u is f of gx. Okay. And then from here to here you can see that y is some function, let's say h of u. So y is becoming like a function of a function of a function. It's a double layer of composite function. Okay, Vinay, this point is clear?
Yes, sir.
Okay, so now the chain rule will accordingly have. So step 1 we've done the substitution. Okay, this was our substitution. Now chain rule step.
So this is only till step 2, right?
Yeah, this is only till step 1, chain the substitution step, right? Now the second step is the chain rule step, right? So dy by dx, how I'll find out. So go back to the beginning of the chain. Okay, so y has been expressed in terms of what? U. So y is a relationship with respect to u. So dy by du. Okay, but then u is itself. Okay,
Into du plus du by dx.
sorry, just a minute. But u is itself a function of z. Okay, so this has to be multiplied with du by dz,
Yes,
and
sir.
finally z is a function of x. So now we have to solve this thing. So there's just like there's an extra step involved. Okay, so d by du of what? So y was cube
To
root
the
of,
power 1 by 3.
okay, into d by dz of what? So z was what? Tan x. Oh, sorry, d by d of u. So u was what? 1 plus z to the power 4. And finally, into differentiation with respect to x of what? Z, which was tan x. Okay. So this will become 1 by 3 u to the power minus 2 by 3, correct?
Yes, sir.
This will become 3z to the power, sorry, 4z to the
4
power
to
3,
the 3.
4z cube. Okay. And
Sec
this will
square
finally
x.
become sec square x. Okay. And then we have to resubstitute. So first of all, I will resubstitute z. Oh no, first I'll substitute u as
1 plus 4, 1 plus tan 4x.
or actually let's substitute z first. No? Z was tan x and u was what? 1 plus tan to the power 4. Okay, so we can substitute that. So u is 1 plus tan to the power 4x and z is equal to tan x. So this we can now write as 4 by 3, okay, z cube sec square x divided by u to the power 2 by 3, and that we can now substitute as 4 by 3. Now z is tan x, so
Sec square.
tan cube x sec square x, okay, divided by now u, which is 1 plus tan to the power 4, this to the power 2 by 3. It becomes a quite a complicated question, as well as even the answer you can see is quite a complicated expression. Okay. So maybe at the moment something this complicated is not required for us in physics. And this is more like an advanced calculus problem from maths. But nonetheless, using the principles that you have learned, you can differentiate this. It's not a problem. It's just that it becomes lengthy. Okay, Vinny, this is clear?
Yes, sir.
Okay. So don't get like perturbed if you see some question like this from some reference book or something. Like it's just like you have to step by step patiently apply the methods that we have learned. However, at this point of time, with respect to your upcoming test and all that, you are not really expected to be able to solve something this lengthy just at the moment. Okay, more like the regular questions that we've seen in your booklet, etc. Those kind of questions,
Okay, sir.
and from the worksheets that I've given you, right?
Yes, sir.
Okay. Now I just want to ask that does anybody have any doubt pending from the earlier worksheets? I'll come to worksheet 4, for which I have not sent the answer key yet. But worksheet 1 to 3, any question that you found you want to revise or discuss while going through it once again? Does anybody have a doubt in worksheet 1 to 3? Because those are extremely important from your upcoming test point of view. Okay, so then let's come to worksheet 4. So we'll do some just give me a moment. I'll share the worksheet. We'll go through it. Okay. Okay, question 5 of worksheet 3, Priyam will pick that up. Okay, just give me a moment. Now, in the meantime, any doubt with any of the questions in
B
this first
question.
part? D part?
Yes.
Okay, we'll discuss anything in what?
B for boy.
Oh, okay, this one. Okay. All right.
So question number 4.
So see, y is equal to e raised power square root of 1 plus x square. Okay. So here we can think of it like this, that take square root of 1 plus x square as z. Okay. So y is equal to e raised power z. So dy by dx will become dy by dz into dz by dx. So dy by dz is e raised power z only, because y is e raised power z into dz by dx. Now think of this like a new problem, that your z is equal to square root of 1 plus x square. So what is dz by dx going to be? So for that, take 1 plus x square as some new variable, let's say u. Okay. So z is equal to square root of u. So dz by dx is dz by du into du by dx. Okay. So I'll just do this over here. So dz by dx will become, now z is square root of u, so its differentiation is 1 by 2 root u. Okay. And u is 1 plus x square, so its differentiation is 2x. So that becomes 1 by 2 square root of 1 plus x square into 2x. So that becomes x upon square root of 1 plus x square. So that is my du by dx. Now we'll substitute that du by dx back here, like a resubstitution.
dz
we
by
get
dx.
dy by dx as dz by du, which is x upon square root of 1 plus x square, into this thing, which is e raised power z. So that is e raised power square root of 1 plus x square. So this is actually a little bit like the double composite function that we had discussed earlier, that tan to the power 4 1. But the thing is, it's in the exponential form now, so it's very easy, because differentiation of exponential is the exponential itself. So it's not that much work, you know. This term is direct, and then this one we are doing by the chain rule. Anyway, is the answer clear?
Yes.
Okay. Okay. Aryan, question 4 of which worksheet? This one, worksheet 4, which I'm showing right now. Okay, I'll come to that. Okay. So just go through this once if required. Okay, understand all the steps. So what we have done is we have applied chain rule here. So from the function we came to this, from that we applied chain rule. Now in the chain rule, this part dz by dx, we made it a separate problem. So we've solved that. That one's result has come this, and then we have finally substituted that back over here. So we've got the final step. Okay, any other part of question 1? Anyone?
So can you do question 1D?
Yeah. So y is natural log of sec x plus tan x. Okay. So you take sec x plus tan x as z. So y becomes ln z. So this we won't have to do a double layer of substitution. This is direct. dy by dx is dy by dz into dz by dx. Now y is ln z, so differentiation of y with respect to z will become 1 by z, and z is this, so dz by dx is differentiation of sec x plus tan x. So that is differentiation of sec x plus differentiation of tan x. Okay. So differentiation of sec x is sec x tan x by formula, and differentiation of tan x is sec square x. So this becomes this last term, sec x tan x plus sec square x. Now resubstitution. So substitute z as what we had here. Okay. So it is 1 upon sec x plus tan x, that's 1 upon z into this term. Now in this term, notice you can take sec x common, and if you take sec x common, you get tan x plus sec x.
Cancel.
So these cancel out. So interestingly, dy by dx comes out to be only sec x. So that's the final answer for this question.
Yes, sir. Thank you, sir.
Okay, any other part of this? Okay. Yes, very good. Okay, so I'll just go back to worksheet 3 for a moment. Okay. And we'll discuss question number 5, then we'll come back to this. So worksheet 3 question number 5 was something like this, that we have given to us an empty cylinder. At t equal to 0, the cylinder is empty and gas is being pumped into the cylinder at the rate of 4 plus t grams per second through an inlet. Okay. So let's say we have a cylinder like this, and there is an inlet pipe through which gas is being let in. Okay. Now at t equal to 0, the mass of gas in the cylinder is 0. Okay. This, let's say, mass. Okay. But inlet is letting gas enter at the rate of 4 plus t gram per second, where t is in seconds. So that means the rate at which the inlet pipe is letting gas come in is actually increasing with time. It's not constant. So at t equal to 0, for example, it's 4 grams per second. But by the time it's 1 second, the rate has become 5 grams per second. By the time it's 2 seconds, the rate has become 6 grams per second, and so on and so forth. Okay. But at the same time, somewhere there is a leakage also. Okay. So there is a leakage where the rate of gas leaking, that is given to us as 2 grams per second. Okay. So now basically we can see that always the rate at which gas is being let in, the inlet rate is greater than the leakage rate. So overall what is happening, we can understand that overall the mass of gas is increasing with respect to time, because the rate of inlet is greater than the rate of leakage. Okay. So far this is clear.
Yes, sir.
It's making sense now what I'm saying. Okay. So now let's say at some time t, okay, mass of the gas is some m. So this is like an instantaneous mass. It's at that moment of time t. So it's an instantaneous value because it's changing with respect to time. So what we can say about the rate of change of this mass? So this mass is m such that dm by dt, the rate at which the mass is changing, that will be equal to the rate of the inlet pipe minus the rate of the leakage. Because both things are happening simultaneously from t equal to 0. So this statement is clear now, Priyam?
Yes, sir.
Okay, so this is 4 plus t minus of 2. So the net rate is becoming 2 plus t. This is the net rate of change of mass of gas in the tank. So this is in gram per second, where t is in seconds. So now you can see that initially at t equal to 0, mass is rising at the rate of 2 grams per second. But after that, the rate also increases. By the time it's 1 second, it's become 3 grams per second. By the time it's 10 seconds, it's become 12 grams per second. By the time it's 1 minute, it would have become 60 plus 2 or 62 grams per second like that. Okay, so this is clear so far?
Yes, sir.
Okay, now the slightly tricky thing, so we have found out the net rate at which the mass is increasing. So that's the first part. Okay. Now the B part, which is a little bit more complex, the total mass of the gas as a function of time. So I have got dm by dt, but from this I need to find out m as a function of time. Okay. So this is like that question we had done earlier, that the rate of change is given and from that we have to guess the function. So here what you notice that dm by dt, or the derivative of the function, it is what type of quantity? It is 2 plus t, which is a linear function. Now, this is linear. So therefore, what we can say about ft? What kind of function's derivative is linear? It should be quadratic. Because when in general, when we differentiate a polynomial of degree n, we get another polynomial of degree n minus 1. So here n minus 1 is 1 because the derivative is linear. So n should be how much? 2. So the function should be quadratic. Priyam, this point is clear?
Yes, sir.
Okay. So this is the main step. For the second partner, this is the main step. To first of all guess that the function must be quadratic. So that's the thing. See, we know that if we have any function of this type, any polynomial going up to a degree of n. So when we differentiate this function, what will happen? This term's derivative will be 0. This term's derivative will be 1. I mean a1. This term's derivative will be 2a1x. Then for example, if the next term was a3x cube, then this one's derivative will become 3a3. So this is a2. 3a3x square. And like that, the last term will become what? N, an, x to the power n minus 1. So if you compare dy by dx with y, what about the degree? Y का degree अगर n था, तो dy by dx का कितना हो जाता है? N minus 1. Okay, understood this point?
Yes, sir.
So here what is happening? The derivative has a degree of how much? 1. The derivative is linear function of time. So it is a polynomial of degree equal to 1. So that means this one, the function itself, this has to be a polynomial of degree 1 plus 1. It has to have degree 2.
Yes, sir.
Understood? In fact, you can say that if this has a degree n, then the derivative should have a degree of n minus 1. So this is a polynomial of degree n minus 1, and that n minus 1 is equal to 1. So therefore, n is equal to how much? It's 2. So it's a quadratic function. So this is the logical thing that we have to apply over here. This is a piece of observational logic that when we differentiate any polynomial, we get another polynomial of 1 less degree. So cubic function differentiated gives us quadratic function. Quadratic function differentiation gives us a linear function. Linear function's derivative is a constant. So its degree is 0, like that. Okay. So if it's a quadratic function, let me understand that suppose m is equal to some at square plus some bt plus c, where a, b and c are unknown constants. Now our job is to find these three so that we know m as a function of time. So what is the first piece of information that we can use? It is that mass was 0 at t equal to 0. So substitute this information in this function. So a into 0 square plus b into 0 plus c should be 0. So that means c should be equal to 0. Okay. Now likewise, so now m is equal to some at square plus bt because c is 0. So if this is the case, now we also know that dm by dt we had seen earlier was 2 plus t. Okay. So that means now differentiate this. This should be equal to 2 plus t, or 2at plus b should be equal to, now I'll just reverse this and write this as t plus 2. So what is the coefficient of t on the left hand side? It's this. What is the coefficient on the right hand side? It's unity. So 2a should be equal to 1. And what is the constant term? It's b. So on the right hand side, what is the constant term? It's 2. So
2.
that means a is equal to half or 0.5 and b is equal to 2. So that means what about the function m now? M we had written it as at square plus bt. So it must be 0.5 or 1 by 2 t square plus 2t. Or we can say m is equal to t square by 2 plus 2. However, we choose to write it. So now you will see that this function satisfies the two properties that we've discussed above. That it's equal to 0 at t equal to 0 and its derivative is equal to 2 plus t. So having understood dm by dt is 2 plus t because it was the rate of inlet minus the rate of leakage. Now the next thing, how to find m as a function of time. These are the steps we have got. Okay. So Priyam, hope this is clear.
Yes, sir.
Okay.
So you perform the reverse of differentiation, right?
That is called integration, but we have not learned integration yet. So we have to do it by this method. Got it now? When we learn integration in the next part of calculus, we can see that such a question can also be solved as a integration problem. Okay. Okay. So any doubt with any of the steps here? Please go through them carefully.
So,
Yes.
sir, that linear part, sir.
See, what is a linear function? It is a polynomial of degree 1. No?
Yes, sir.
So linear function in general, the definition of a linear function is that it is a polynomial function but of degree 1. So it's like this kind of power series that we are written. Y is equal to a naught plus a1 like that. But here it's only up to n equal to 1. So it's like we can write it like this also, or we can write it in the more standard form y is equal to mx plus c, where m and c are constants. Okay. Whereas what is a quadratic function? A quadratic function is a polynomial of degree 2. So we can write it like this, or we can write it in the more standard form as ax square plus bx plus c. But the important thing to notice is that if I have a quadratic function, then its differentiation will automatically be a linear function. If I have a linear function, then its differentiation will become a constant term. Dy by dx here will be m, which is a constant. So you can also think of it like a polynomial of degree 0. Okay. Whereas if you have a quadratic function, its derivative like this one over here is becoming 2ax plus b. Now the 2a is a constant. So this is which type of function now? This is linear. Okay. Like that, if I have a cubic function, its derivative will become quadratic. If I have ax cube plus bx square plus cx plus d, its derivative will become a quadratic. So this is cubic. Its derivative is becoming quadratic. So always the degree becomes 1 less. If I have a polynomial function of degree 5, then its derivative will become a polynomial of degree 4, like that. Okay, so these terms are clear?
Yes, sir. Yes, sir.
So this is like an important little concept to understand in differentiation, that when we talk about polynomial functions, any polynomial function's derivative will have a degree of 1 less than the polynomial function. Okay, so let's go back to worksheet number 4 then, and continue with our run through of the questions. Okay. Share. No, not this either. Okay, so question 1 is done. Or if there's any other part of question 1 someone wants to discuss, please let me know. Okay, let's come to question 2 and 3 then. So anyone has a doubt in question 2? Okay, what about question 3?
Sir, in question 3, we can use similar triangles, right?
Yes, exactly. You can use similar triangles. In fact, that is what you have to do here. Okay. So you can use similar triangles in such a way that you can see that if this distance is x and this distance is y, then first consider this triangle where you have the person's height as the height of the triangle and the shadow of the person as the base of the triangle. Okay. And this angle is some instantaneous theta. And then consider along with it the larger triangle where the person was here, but now the larger triangle is using the lamppost. Okay, so this is 5, and this whole thing has now become y plus x, subtending the same angle. So comparing these two, I'll have the relation that y plus x upon 5 is equal to x upon 2. Now what is happening? Y is initially, how much is it now? It's 10 meters, right?
10.
Yeah. At t equal to 0. But y is decreasing because the person is moving. So you can see that dy by dt, or you can even write it as delta y by delta t, assuming he's moving at a constant rate. So dy by dt is minus 0.5 meters per second. So after some time t, y would have become 10 minus 0.5 t at t equal to t seconds. For example, after 1 second, it would have become 9.5 meters. After 2 seconds, it would have become 9 meters. So after 4 seconds, it is assuming the speed is constant. It will have become 10 minus 2 or 8 meters, like that. Okay. But important thing is y is going on decreasing. So accordingly, x will also go on decreasing. So the relation between x and y here will become like this, that y by 5 is equal to x into half minus 1 by 5. So y by 5 is equal to 3x by 10, or y is equal to 3x by 2, or if we invert this, that means x is equal to 2 by 3 y. Okay. So I can see that if y is decreasing like this, then x is also decreasing. But x is decreasing like this, that it is 2 by 3 into 10 minus 0.5 t. So as far as the question is concerned, it's only about whether they're decreasing or increasing. So we can see that x is decreasing with respect to time. That means this point, which is the tip of the shadow, is with respect to this point, which is the person's location, the distance between the two is decreasing always, because x is decreasing. So because x is decreasing with respect to time, so we can see that this is always coming closer to the person. So the answer to the first part is that the tip of the shadow is moving in which direction? It's moving towards the person. It's not moving away. Okay. Now similarly, the tip of the person with respect to the lamp, that is at a distance of how much? X plus y. Okay. So let's say x plus y is s. So this is what the instantaneous distance of the tip from the lamp, from the lamp post. So what is happening to s? X is decreasing with respect to time. Y is decreasing with respect to time. So s is also decreasing with respect to time. So s is decreasing. So if s is decreasing, that means this one is also moving in which direction? Towards. It's moving towards the wall and not away from the wall. So basically, this is the wall.
Sir, if rate was asked, then what should we do?
Sorry, if
Rate of decreasing was asked.
if that is asked, then you have to just calculate this. So for example, x we have calculated now. X का as a function क्या आ गया? Okay, it's come as 2 by 3 of 10 minus 2 by 3 of 0.5 into t. So just differentiate that. So dx by dt will become how much? 2 by 3 into 0.5 with a minus sign, right? So minus 1 by 3.
Okay.
Understood, beta?
Yes, sir.
Similarly, if you ask what is the rate at which the tip is coming closer to the wall, so that is the rate of s changing with respect to time. So s is what? X plus y. So that is this plus this. So that will become x is 2/3 of y. So it will become 2 by 3 plus 1. So 5 by 3 times y. So just note down this part if required, then we'll discuss that. Okay.
So what's the difference between the tip of the shadow and the length of the shadow? It is asked.
Sorry, what is the?
If
What is
tip
this?
of the shadow, if the rate of decreasing of tip of the shadow is asked, then what?
Didn't understand, beta. Speak a little louder. Come again. If what is if the what about the tip is asked?
If the rate of decreasing of the tip.
See, the tip is not decreasing. The shadow length is decreasing. You understanding the point?
Shadow
shadow
length is decreasing, then tip should also decrease, right?
नहीं टिप तो एक पॉइंट है ना बेटा. टिप तो शैडो में एक पॉइंट है ना. यू अंडरस्टैंडिंग? शैडो का लेंथ क्या है? इट इज अ क्वांटिटी x which I have shown in the diagram ना. So x is decreasing with respect to time. But what about the tip? Tip is just moving, na. It's not decreasing or increasing. The tip is a point. Are you understanding?
So for that we have to take a reference point like the wall or the lamp.
But if I ask you, what about the distance of the tip from the wall? Okay, so then your reference point is the wall, no? So what is the distance of the tip from the wall? It is x plus y in my diagram.
Yes, sir.
Now I have x as a function of time. I have y as a function of time. So from that I have the distance of the tip from the wall as a function of time.
Understood.
Got it, no? Okay. Okay, so once see I've got the value of x and y here. Now the rest is simple. If like in this question, it was only asked whether it's coming towards or away from. So that we've already seen. Okay. But now if I ask you, what is the rate at which the shadow length is decreasing? Or what is the rate at which the shadow's tip is coming closer to the person? So that's nothing but, okay. So shadow length, that is x. So the rate at which the shadow length is decreasing, that is nothing but dx by dt. So that will be nothing but 2 by 3 of dy by dt. No? Because that was the relation between x and y. Okay. X was equal to 2 by 3 times y. This was the relation. And dy by dt is minus 0.5. So the rate of change of the shadow length is 2/3 of minus 0.5. So that is minus 1/3 or minus 0.33 meters per second. So the shadow length is decreasing at the rate of 0.33 meters per second. Or you can say the tip is coming closer to the person at a rate of 0.33 meters per second.
So the negative sign shows the decreasing. Right?
Yeah, negative sign is to show that it is decreasing. So X is decreasing at the rate of 0.33 meters per second. If X was increasing, then we would have written it with a plus sign, right? Dx by dt. Okay, this is clear now?
Yes.
Okay, now similarly, we want to find the rate at which the tip is coming towards the person, towards the wall. So we just make use of that thing, no? That the distance of the tip from the wall this total distance is, let's say, S. So S equals to X plus Y is the distance of the tip from the wall. Okay, so S we can write as 2/3 plus 1 into Y using this. Okay, so we can write as 5/3 times Y. So now the rate at which the distance is changing is 5/3 times dy by dt. So that is 5/3 into minus 0.5. Okay. So again, the minus sign is showing that S is decreasing with respect to time. So the distance of the tip is decreasing with respect to the wall at the rate of 0.83 meters per second. Yes. Any doubt?
Sir, in the second part, we can just logically tell that since that tip is moving towards the person and the person
towards
is moving
or
towards the wall.
away, that we can understand logically only. Both of we can just, we can just see that after some time when the person is here, let's say,
Shadow will be
the
near
shadow is like
towards.
this. So we can see the shadow length is also decreased. Plus this point has come closer to this.
Yes, sir.
Okay. But if we were, for example, in the same question asked to find the rate at which it's changing, so that would require this differentiation kind of calculation. So yeah, you're correct in saying that in this particular question, we don't need to use differentiation at all. We can just use similar triangles and compare like that X and Y have a proportionality relation. So if they have a proportionality relation, that means whatever is the behavior of Y, the behavior of X is the same. So if Y is decreasing with respect to time, then so is X. So accordingly, we can see that the shadow length is also decreasing, plus the shadow is coming closer to the wall. Okay, now this question is clear fully, people?
Yes, sir.
Yes.
Okay, very good. Okay, just give you a minute if you need to note down anything over here, then we'll move on to the next page. Okay, so let's move on. Okay, I'll wait, finish writing now. Okay. Let's move on to the next section. Sorry, some numbering error again. This should be question 5. Anyhow. So this is that type of question where we have to find the intervals where y is increasing or decreasing with respect to x. So tell me if we need to solve any of the parts of this. The first part is very much like a question we did today. Okay. Few of the parts are a little bit complicated here, so I'll discuss with you. Question 4, okay, I'll discuss question 4 also. Yes. G will do, okay, yes. So question 4 is very much like the example we had done that day in class, only the values are different. So what is happening is this is coming down at the moment at the rate of 15 feet per second. Okay. So that means this distance is a variable. So let's take it as x. Okay. Whereas this is a constant distance because the person is at rest, he's not moving. So the person is stationary, that means this distance we can take it as a constant. So d is equal to 500 feet given. Okay. But x is instantaneous value is 200 feet and v is equal to 15 feet per second. Okay. So this is obviously an instantaneous value. Okay. So from that you can also see that the angle of elevation at that moment is tan inverse of 2 by 5. So this is also an instantaneous value. Okay. Now what is happening? X is decreasing with respect to time. So accordingly, theta will also be decreasing with respect to time. Okay. Such that we can see that dx by dt is directly minus 15 feet per second because v is given to us this. Okay. So now we have to find d theta by dt. So to find d theta by dt, we first need to find the relationship of theta and x. Need to find this relation and then use chain rule in that. Okay, so just note down up to here if you like, then we'll discuss how to express that relationship and apply the chain rule. Okay, so now let's see the relationship between these things. So you can see that tan theta is equal to x by t, where theta and x are instantaneous quantities, whereas d is constant. So if we differentiate this, the rate of change of tan theta with respect to tan, that is the left hand side of the equation, should be equal to the rate of change of right hand side of the equation. On the left hand side, we have to use chain rule now. So differentiation of tan theta with respect to theta into d theta by dt. So this step here is the chain rule. Okay. Right hand side, we don't need to use chain rule because capital D is a constant. So it's directly dx by dt. So differentiation of tan theta, you know, is sec square theta with respect to theta into d theta by dt is equal to 1 by d into dx by dt. Okay. So now we can see in this diagram that dx by dt is equal to minus b. Okay. So from this, the rate of change of theta will become cos square theta by d into minus b. Okay. At the given instant, what is the value of theta? So let's understand that. So this is 200, this is 500. So we can write this as, let's say 2a, this is 5a, where a is 100. So this will become square root of 29a. So cos theta is based upon hypotenuse, so it's 5 upon square root 29. So cos square theta is 25 by 29. So this we will substitute here. So at the given instant, our d theta by dt will become 25 by 29, that's cos square theta, divided by b, which is, sorry, d, which is 500, into minus of b, that is minus 15. So this will become our answer. Okay. So this will give us minus of 25 by 29 into 500 into 15. Okay. So 25 will go 20 times here, so this will become 3 by 4. So d theta by dt will become minus 3 by 4 into 29. So that's 36 plus 80, 116. So d theta by dt will be this in SI units because feet will cancel out. So it is per second. So d theta by dt's value will come out to be minus 3 by 116 radians per second. Okay. So that should be our final value. That d theta by dt is minus 3 by 116 radians per second, just as dx by dt is minus 15 feet per second.
Sir, but how do we know that it is in radians only? Like there's no unit given anywhere in the entire calculation. Like for the distance.
Little bit louder, please, but I can't hear you.
Sir, how do we know that it's radians per second only? Like in the
because see,
distances it's given feet, so we can know that it's in feet.
No, but feet cancel हो जा रहा है बेटा. देखो वो जो इक्वेशन है ना cos square theta into minus b by d, उसमें v का यूनिट क्या है feet per second और capital D का यूनिट क्या है feet, right?
Yes, sir. So I was
And
saying
cos
that
square
in the
theta is
unit
dimensionless, right?
Yes, sir.
So what is the unit? It is per second. Now when we express an angle in SI unit, what is the angle? It is radian.
Yes, sir.
Radian is unitless.
I didn't get that. Radians is unit.
An angle in radians is basically what? Arc upon radius. Na? So one radian is actually unity because arc length is equal to the radius in the case of one radian.
Okay, okay, sir. Got it.
Okay, so let's move on to question. Okay, finish writing. Okay, fine. I'll just give you a minute to take anything down from this if required. Okay. Okay, so let's move on. So question 6. So what I would suggest is let's start with part C. Okay. So part C, y is equal to x plus 1 by x. So dy by dx is equal to 1 minus 1 by x square. Okay. So therefore, dy by dx is positive, means that 1 minus 1 by x square should be positive. Okay. Which further means that 1 by x square should be less than 1. Take this on that side. Okay, which means that x square should be greater than 1, which means that x should be greater than 1 union with x should be less than minus 1. So that means y is increasing for x belonging to minus infinity to minus 1 union with 1 to infinity. So this is the first thing, the interval in which the function is increasing. Then we'll come to the decreasing one also. Okay, so any doubt in this solving of the inequality, please let me know. Okay, now to find the part where y is decreasing with respect to x, we have to solve for dy by dx being negative or less than 0. But before we come to that, now we should understand one important thing here, that this function is such that x should not be equal to 0 because y is not defined for it. So the domain of the function is like this. It is minus infinity to 0, but excluding 0. So union with 0 to infinity. So it is all negative and positive values of x, but not including x equal to 0. We should keep that in mind also. So anyway, y is decreasing with respect to x for dy by dx being negative. So 1 minus 1 by x square being less than 0. So 1 by x square being greater than 0. So greater than 1. So x square being less than 1. So x square being less than 1, generally speaking, means minus 1 to 1. But here remember 0 is not included. So the point 0 should not be included. So the solution of this will become x belongs to the interval minus 1 to 0 union with 0 to 1. So y is decreasing for this interval of x. So basically, if you think on the number line, so it's increasing in this part of the domain up to minus 1, then it decreases up to 0, further decreases from 0 to 1, and then again increases after. but 0 is an excluded point from the domain. So 0 is not there in my domain. Okay, now Yashovardhan has asked part G, so we'll discuss that. Okay, so first thing we need to do here is find dy by dx. So for dy by dx, we'll use chain rule. Okay. So sine x can be treated as z. So y is e raised power z. So therefore, dy by dx will become differentiation of e raised power z into differentiation of z with respect to x, which is cos x. So cos x into e raised power sin x. That is a derivative of the function. So yes, this is clear. Okay. Now that we have found dy by dx, now to find where y is increasing or decreasing, we have to solve for this. So y is increasing for dy by dx to be greater than 0. So we want cos x into e raised power sin x to be greater than 0. Now you'll realize this thing, that this actually implies that cos x should be greater than 0, because e raised power sin x is greater than 0 for all values of x. Okay. So the important thing here is that e raised power sin x is greater than 0 for all x, because for all x sin x ranges between -1 and +1. So e raised power sin x, this ranges between e raised power -1 and e raised power +1. So this is also a positive number only. This is also a positive number. So e raised power sin x is always positive. So whatever value of x I take, this factor is always positive. So for the product of cos x into this factor to be positive, cos x has to be positive. So that's again x belongs to 0 to pi by 2 union with 3 pi by 2 to 2 pi. Oh, sorry. This should be in open bracket 3 pi by 2. And 2 pi should come with the close bracket. Okay. And similarly, for y to be decreasing with respect to x, cos x should become negative. So that is between pi by 2 and 3 pi by 2. Okay, let's also do the h part. Okay. We'll come back to these three if required. Okay. But let's solve the h part as a class exercise problem today, because many of you might not have attempted this yet. Or if you have done the question, just send me the answers you got for each part. Just send me a text with the answers. I'll verify it for you. I'll do the question in a minute. Okay, just try it out. Yes, Jinendra, your answer is correct. Okay. Darsh, your answer is correct in terms of what you have said, that it's unchanging at those points. But where it's increasing and decreasing, you still have to give the answer. Okay. Okay, so let's look at this function x to the power 4 minus 2x squared. So worksheet 4, question number 6, last part. That is h. We want to find the intervals for y to be increasing with respect to x or y to be decreasing with respect to x. So first step, dy by dx. So that is 4x cube minus 4x. So we can nicely factorize that and write that as this. Okay. So now when we are solving the inequality that dy by dx is greater than 0 or less than 0, we can use the wavy curve method that you might have learned in maths. It means that 4x cube minus 4x is greater than 0. That means 4x into x minus 1 into x plus 1 is greater than 0. Okay. So we will use the number line or wavy curve method. Okay, because we have the product of three things. Okay. So let's say this is our overall number line. Now you'll see here critical points are 0, minus 1 and plus 1. Now if you consider the first factor here x, okay, 4x or x, whatever, that is negative for x less than 0 and positive for x greater than 0. So that's the factor 4x. Okay. Then if we consider the factor x minus 1, it is negative for x less than 1 and positive for x greater than 1. And then if we consider the factor x plus 1, it is negative for x less than minus 1, sorry. And it becomes positive for x greater than minus 1. So you can see that we have divided our number line into three regions. So now when we look at the product of these three quantities, when we look at 4x into x minus 1 into x plus 1, it's product of three negative quantities, so it's negative here, then positive here, then again negative here, then again positive. So if we look at the function fx, because this is the derivative of the function, so the function should have a nature where it is increasing in this region, sorry, decreasing in this region because this is negative, then again increasing in this region, then again decreasing in this region, then again increasing. So the graph of the function should be something like this, where this is x equal to 0, this is x equal to minus 1, this is x equal to plus 1. So anyway, so we can see that y increases for x in the interval minus 1 to 0 union with 1 to infinity, greater than 1 or between minus 1 and 0. And y decreases for the interval minus infinity to minus 1, this one, union with 0 to 1, this one. So a solving of an inequality like this is a little bit complicated in terms of algebra. Okay. And wavy curve method is a very useful method for solving that. So this number line method, another name for it is you're familiar with this wavy curve method in maths?
No.
अभी recently maths में नहीं किया है अभी तक?
Not
sir.
yet, sir.
Sir,
No.
Okay, then you will be learning very soon.
We'll start
It's
it.
part
the
of
next
basic
week.
maths. But you understood the method
Started
here?
it, but it will happen next
You
week.
started. Okay. So you understood what we've done over here in this number
Yes,
line method?
sir.
Okay.
Yes, sir.
Yes,
So
sir.
each of the three factors, no, 4x, x minus 1 and x plus 1, we are looking at the regions on the number line where they are negative and positive. And
Sir,
from
I didn't understand how you removed the number minus 1, 0 and plus 1. So is it like random numbers or is it?
नहीं random number नहीं है बेटा देखो 4x के लिए critical point क्या है 0 है ना because 4x is less than 0 when x is less than 0.
हाँ तो 0 समझा पर minus 1 और 1
हाँ तो अभी देखो ऊपर वाला point देखो x minus 1. x minus 1 is 0 at which point 1 ना.
अच्छा तो आपने ऐसे करके वो point लिया.
और x plus 1 के लिए critical point क्या है -1 है ना.
हाँ correct समझ गया sir.
So मतलब when on this side now when I'm seeing this equation only here this one now, so I can see that this is becoming 0 at 0 or 1 or -1. So I understand
So
that on my number line those are the critical points.
सर तो अगर वहाँ 4x x square minus 4 होता तो x minus 2 x plus 2 होता तो आपके यहाँ reference point -2 0 और +2.
Yes, correct. Absolutely. So those are the critical points in my analysis. You know? Okay, so now coming back to just what all you have to do before the test now. So for example, in worksheet 4, this question 6 is not important from this point of view of your test coming up because this behavior of the function increasing or decreasing, that part will not be tested on Sunday's test. But the differentiation part in this sixth question is also important, like how we differentiated e raised power sine x or how we differentiated x plus 1 by x. That differentiation part is part of your test, but then the further analysis that dy by dx is greater than 0 or less than 0, that will not be coming in this upcoming test. Okay, but similarly at the same time, the question that we did of that thing that volume was changing or that what was the question we did just now? Question number 2 or something. One of them where we calculated rate of change. Yeah, that thin ice sheet. We didn't solve this question, but this is part of the sheet. That thin ice sheet, which is in the form of a circle. Okay, it is melting in such a way that the area is decreasing at 0.5. So that type of question is also important. Okay, so in worksheet 4, all the parts of question 1, then 2, second question, that is important. Okay, whereas third, fourth question are a little bit more difficult application of rate of change. So that is not important for your test coming up on Sunday. And sixth question, again, the differentiation is there, but the application of differentiation, that is dy by dx being positive or negative, that you need not do for the test coming up on Sunday. So basically concentrate more on the application of the methods of differentiation, like chain rule, product rule, and quotient rule. And for the application of differentiation, just the simple area and volume type of questions that we've done up to worksheet 3. Okay, people. So hope it is clear. Okay.
Sir, so we won't have to find the function from the derivative, right?
Yes, basically that type of question. Okay.
No, sir, because in that one question where we had to find mass as a function of time and the derivative was given to us. So that is
वो हो सकता है ना, वो तो सिंपल है बेटा, मतलब जैसे लीनियर फंक्शन है डेरिवेटिव तो function क्या होगा? Quadratic function होगा. So that's a simple application only, ना?
Okay, sir.
Okay, so make sure you revise that also. Okay.
Okay, sir.
Worksheet 1, 2, and 3 revise everything. Okay.
Yes, sir.
Okay, so those type of questions were there in worksheet 2 and 3. So revise that. Huh?
Okay, sir.
Okay, people. So wish you all the best. I'm sure that if you revise all the class notes and the worksheet problems and things, you should not have any difficulty with the test coming up. Okay. There'll be approximately half the questions in physics will be from vectors and half will be from calculus. Okay. So make sure that you revise vectors also very carefully. So that's it for today's session, people. Wish you all the best. Okay.
Thank you, sir. Bye, sir.
Okay. Bye.
Thank you, sir. Bye, sir.
Thank you, sir.
Okay. Bye, people. Bye.
Thank you, sir. Bye, sir.